Welcome to Chopra School of Physics. Now, in our last videos we have discussed about the Lorentz forces, and now we come towards once more a brief review for applying the permittivities and permeabilities in Coulomb's law, in potentials, in capacitance. Everywhere we are going to use permittivities and permeabilities. So, now the point to remember, we write like this. Three symbols are taken. These are the three symbols. First symbol is called permittivity. The second one is known as absolute permittivity. The third one is known as relative permittivity. I will repeat: permittivity, absolute permittivity, the relative permittivity. This relative permittivity is also known as SIC, specific inductive capacity. So, epsilon R, epsilon, epsilon naught, epsilon R. Permittivity, absolute permittivity and relative permittivity. This relative permittivity is also known as specific inductive capacitance. So SIC, or it is DEC, dielectric constant. I have earlier explained. D stands for dielectric, DE constant, dielectric constant. Now, for first two symbols, the unit is very important. So, permittivity and absolute permittivity. Before stating the units, the relation will be epsilon is equal to epsilon naught multiplied epsilon R. So, what is permittivity? So, we have a brief definition. It is the product of absolute and relative permittivity. For permittivity and absolute permittivity, the units are same. The units will be Coulomb square per Newton meter square, or Farad per meter. Coulomb square per Newton meter square or Farad per meter. That is 1 Farad per meter and 1 Coulomb square per Newton meter square. They are numerically the same. And relative permittivity of medium will be epsilon over epsilon naught. So what is dielectric constant? The relative permittivity or dielectric constant is the ratio of permittivity and absolute permittivity. Whatever is the unit of permittivity, same is the unit for absolute permittivity. Therefore, if we compute the units will cancel off, and relative permittivity has no units. So, dielectric, no units. No units. Dimension, dimensionless constant. So for relative permittivity there will be no dimensions. Now, when we use this term relative permittivity is that which is calculated with respect to absolute permittivity. So point to remember, relative permittivity calculated with respect to absolute permittivity, and absolute permittivity of different mediums will be different. Therefore, epsilon r or DEC, dielectric constant of different mediums, will be different. We have come to the reasoning question that why different mediums have different dielectric. Different mediums have different dielectric because their absolute permittivities are different. So absolute permittivity of different mediums will be different. That is a characterization of the medium. So if absolute number will change, the relative number will also change. Now, we must know that what should be the relative permittivity of air medium with respect to absolute permittivity, and what should be the range of dielectric constant, and what should be the range of permittivity. Now, the point to remember, that is for air. For air or vacuum. For air or vacuum. For air or vacuum, that is free space. As earlier explained, free space. Relative permittivity of air is 1 with respect to absolute permittivity of air, and absolute permittivity of air is 8.854 10 to the power minus 12 Coulomb square per Newton meter square. So here I have written epsilon and epsilon naught, that is Coulomb square per Newton meter square, or other unit was Farad per meter. So instead of using this unit, we can use this unit also. So relative permittivity of air is 1 with respect to absolute, and absolute permittivity of air is this one. Now what is permittivity of air? Permittivity of air. What is the formula of permittivity? The product of the two numbers. That is product of this number and this number. If you multiply this number by 1, you will again get the same number. And if you observe this number, it is of the order of 10 to the power minus 12. Obviously, permittivity of air less than 1. Because 10 to the power minus 12, that is obviously less than 1. So now, permittivity of air is always less than 1, but permittivity of medium other than air is greater than equal to 1, and it varies up to 10. So this is the point to remember for most of the questions, because these fundamentals are not given for the solution of numerical problems. Permittivity of a medium other than air greater than equal to 1, maximum varying up to 10. And 10 stands for titanium oxide. So now our question is, the maximum permittivity stands for which medium? And the right answer will be titanium oxide. The value is 10. So these are all the parameters for air. Relative permittivity of air this one, absolute this one, permittivity of air 1, and permittivity of a medium other than air 1 to 10. Now the point to remember, dielectric constant varies from 1 to 80 or 81 at the most. Maximum 81. Or as a whole number it should be 80. So 1 to 80 or at the most up to 81. 1 stands for air and 80 stands for water. So dielectric maximum is 80. This is the maximum value of There is no medium whose dielectric is ever greater than 80. That is only for water. So range of dielectrics 1 to 80. Range of permittivities 1 to 10. And the general formula of dielectric constant is 10 to the power 12 over 8.854 into absolute permittivity of medium. This is the general formula for getting dielectric constant of a medium, 10 to the power 12 by 8.854 into absolute permittivity of medium. We have talked much about the permittivities, their mathematical formulas, their range, and dielectric for metal that is almost infinity, that is number by 0, 0 by 0, infinity by infinity. This is called indeterminate form. Indeterminate form. You will know much about the indeterminate form in the differential calculus when we will discuss about the limits of the functions. So these are all about the dielectric constant, permittivities. And now you must be aware of what is the definition of permittivity. Permittivity is the power of conduction. Permittivity is a term derived from permission. So permittivity is the power of conduction of electrical lines of forces depending upon electrical properties of medium. Whether medium is good conductor, a semiconductor, or an insulator. So, when we use the term permittivity, it is nothing, it is basically power of conduction of electrical lines of forces. And electrical lines of forces are conducted more or less will depend upon the nature of medium, whether medium is good conductor, semiconductor, or insulator. So, permittivity of good conductors greater than permittivity of semiconductors greater than permittivity of insulators. So what is permittivity? Power of conduction. Power of conduction of what? Electrical lines of forces. Permittivity is an electrical phenomenon. So permittivity of good conductor more than semiconductor, more than insulator. Semiconductors are generally fourth group elements. Fourth group elements. Fourth group elements. They are in the form of germanium and silicon. Fourth group elements. And they exhibit the properties of metalloids. They exhibit the properties of metalloids. So, semiconductors will be elaborately explained to you in the chapter of solids and semiconductors or the electronic devices. So here at this stage only you will remember that permittivity of semiconductors is less than this, but it is more than insulator, and insulators which do not conduct electricity or they do not allow electricity to pass. So this is all about the permittivities. And next concept related to the same, that is called permeability. Well, so now we have completed the portion of permittivity, the general formula of permittivity, and next is a similar concept related to magnetic effects or magnetism, and that is called permeability. So for permeability, we must know the definition, It is the power of conduction of magnetic lines of forces, and other is the mathematical formulas and their units. Thank you.